Hi students, this is our second video session on the growth techniques of nanomaterials. In today's video class, we are going to discuss the first synthesis technique of nanostructures, that is plasma arc discharge. Now plasma refers to an ionized gas system. Normally, gases are not conducting, but they can be made conducting. How is it done? A gas can be made conducting by applying a potential difference in a gas system. As a result of the applied potential difference, the gas will ionize. The gas ionizes to form positive ions and electrons. That is, it forms plasma. So plasma consists of electrons, ions and neutral atoms. And this plasma is highly conducting. This is how a gas can be made conducting. So I hope it is clear to all of you. Gases are normally non-conducting, but when a high potential difference is applied to a gas system, it ionizes to form positive ions and electrons. This mixture of positive ions, electrons and neutral atoms is called plasma, and the plasma is highly conducting. Now in this technique, we are using a plasma arc discharge to produce or synthesize nanostructures. Now due to the high conductivity of the plasma, an arc is generated between the two electrodes which produces heat. Now what is meant by an arc or an arc discharge? An arc is a continuous electrical discharge between two electrodes with visible discharge of light. That is, the plasma will be in this form. That is, an arc discharge is taking place here. An arc is a continuous electrical discharge taking place between two electrodes which is emitting visible light. So this plasma arc discharge is used for the formation of the nanostructures. Let us see how. That is, the electric arc passes from one electrode, that is the anode, to the other electrode, that is the cathode, due to which the anode vaporizes and it gets deposited on the other electrode and the chamber walls to form the nanostructures. So what is happening? The electric arc will pass from one electrode to the other. As you can see in this figure, the electric arc is passing from, this is the anode and this is the cathode. It is passing from the anode to the cathode, which results in the vaporization of the anode. That is, the anode atoms are getting ionized and ejected, and they deposit on the cathode to form the cathode structure. In the example shown here, carbon nanotubes are the nanostructures which are being formed. Here the carbon nanotube is formed on the cathode. The anode and the cathode are graphitic anode and a graphite anode and a graphite cathode. That is, both are made of carbon. So this is how we use a plasma arc discharge for creating nanostructures. In the carbon nanotube deposition, carbon electrodes are used. Here the carbon cations produced by arcing move towards the cathode. They pick up electrons, become neutral and gets deposited to form the carbon nanotubes. Boron and silicon nitride nanotubes are also produced by plasma arc discharge method. Here the electrodes must be made of conducting materials. The electrodes can also be made of, it's not electrons, it's electrodes. The electrodes can also be made of a mixture of conducting and non-conducting materials. Then, in such cases, during heating, the non-conducting material gets heated and vaporized and ionized, and it becomes a part of the plasma arc and is transported and deposited onto the cathode. Another variation of plasma arcing is the flame ionization technique, in which the material using which the nanostructure has to be formed is sprayed into a flame, whereby the ions are produced which are collected and deposited in a nanocrystalline form. So I hope the method of plasma arc discharge is clear to all of you. So we'll meet in the next session. If you have any doubt, please do contact. Thank you.